Derivative.
Detective Derivative, it's your Sugar Maple Queen, of course, but I really need your help. You see, I was riding in the Sugar Maple Festival, in the car, and all of a sudden a bullet came flying, and it hit me in the leg. I really need you to help me solve the problem with your math skills.
Alright, of course I can help you. I think it would help if we started at the scene of the crime though in downtown Belleville. So, I'll meet you there. Alright, see ya.
So what did you find, Detective?
After looking at the crime scene, I found the weapon used in a dumpster and test fired it to find that the most velocity is 10 meters per second.
Very interesting. Well, I found from eyewitness accounts that the time it took from the bullet to be fired to hit Carly's leg was 3.1452172 seconds, and also the gravity in Bellbrook, as it happens to be, is negative 9.8 meters per second squared. And also, the height that Carly's leg was hit at is 2 meters because she was standing on a float.
Alright. I also talked to the owner of Macintoshes, who said that he gave me the floor plans and said that the first floor is 5 meters above the ground, second floor is 15 meters, third floor is 25 meters, and the fourth floor is 35 meters. So I guess we have to use this information and our math skills to find out the trajectory of the bullet.
Yes, and find out which floor was the culprit. Okay, so we have the acceleration of the bullet. We can use that to find the velocity of the bullet because we know that velocity and acceleration are related because acceleration is the derivative of velocity and acceleration can be integral to equal velocity.
Alright.
So, let's write that on the paper. Alright. Since we know the acceleration equals negative 9.8 meters per second squared, we have to take the integral of acceleration to find velocity. And that velocity function would then equal now we have to find what this baby c equals. Well, let's use our information. We know that at the initial velocity v of t equals 0, the initial velocity is 10 meters per second. So 10 meters per second at time equals 0 has to equal c. So if we cross this out, 10 equals c. So then we know that the velocity function is this.
Alright, thank you. We're also going to find the position, and to do that we're going to take the integral of the velocity function. So, to start off, let's take the integral we're going to find that it's going to be 9.8 t squared over 2 plus 10t plus baby c. That is the new position function. Alright, so we have the position function that we found by taking the integral of the velocity. We also have the time that it takes from the time that the bullet got fired until it hit the Sugar Maple Queen in the leg, which was at a height of 2 meters. So now we're going to plug it in, the time, into the position function to find the initial height, which is baby c. I'm going to abbreviate the time because it's so long with the ...
And we know that that equation right there is going to equal 2 because that's the height at that time.
Yes.
Now after doing some math, we found that the initial height that the bullet was shot from was 25 meters. Alright, we know that the initial height the bullet was shot from was 25 meters. So look on your map of downtown Bellbrook's building heights, and what floor is that?
That is the 3rd floor of Macintoshes.
Alright, Macintoshes? That's where Scott Johannes lives. He must be the criminal.
That's him!
You're under arrest!
What? Oh, jeez! Oh, God, ow, what did I do? What did I do?
You shot the Sugar Maple Queen.
What? What? That is preposterous.
Yes,
how
you
would
did.
How would you know that?
We did calculus.
Ow! You did calculus?
Stop fighting.
Oh, my God, I hate that stupid crap. I just majored in English. I didn't think I'd need that crap. Oh,
All right, another calculus crime solved.